Today in class we did review for Chapter 2, the Chapter 2 test. And what I'm going to do today, though, is go over 2.7, which is a section that we could probably spend a little bit more time on. We did graphing by hand, but the key here was finding these values, the horizontal asymptote, vertical slant, x-intercepts, and y-intercepts. So the first thing I'm going to start with are actually these last two items here. As a reminder, I'm going to go back to my coordinate plane. Now I just graphed two arbitrary points here, but this is an example of an x-axis. So we have x, and then our y value is always going to be 0 no matter where we are along the x-axis. Our y-intercept is always going to have an x value of 0, and then our y. This is going to help us when we're actually figuring out what our x and y-intercepts are. So let's go back to this. When we solve for our x-intercept, that means that I'm looking at where y is going to equal 0. In other words, I'm going to set my whole equation equal to 0. So 0 equals x plus 3 over 2x minus 3. Now here's where I can just use simple algebra to figure out what x is going to equal at this point. So I'm going to multiply each side by 2x minus 3. And you may not even need to do that step. You may recognize it doesn't matter what the denominator is, because when you multiply it by 0, you're going to get 0. So you could also just skip straight to this part where we have our numerator set equal to 0. So we set our numerator equal to 0. Of course, subtract 3 on each side. Negative 3 equals x. So what that means is that at negative 3, 0, I have an x-intercept. So I would write here for my x-intercept, I just have 1, and it's negative 3, 0. My y-intercepts, looking back at this, is where x equals 0. So easy enough, I'm just going to take this same equation and set x equal to 0. So I've got 0 plus 3 over 2 times 0 minus 3. That's 3 over negative 3, which is equal to negative 1. So that means that we have a y-intercept at 0, negative 1. Now let's look at our asymptotes. This is where we actually start applying those rules. So for a vertical asymptote, and I know I'm going out of order here, but for a vertical asymptote, what I'm looking at is my domain. So I'm going to look at the denominator. I know that my denominator cannot equal 0. So when I add on each side, I get 2x cannot equal 3, so x cannot equal 3 halves. That means that my vertical asymptote is where the domain is not. So if that doesn't sound confusing enough, think about it this way. If the domain cannot be x equal to 3 halves, that would mean there has to be something blocking it. That is my vertical asymptote. The vertical asymptote at x equals 3 halves. Now for the horizontal asymptote, that's where I look at my rules of the numerator and denominator. I notice that the powers are the same. I've got a power of 1 for each of these. So that means that I'm going to divide my coefficients in order to find what that horizontal asymptote is. So I have 1 over 2 essentially. So that means that my horizontal asymptote as y equal to 1 half. I couldn't cancel anything out, so I don't have any holes. And the other thing that I can see that I do not have a slant asymptote because the powers are the same. The power were higher in the numerator, then that's where I would actually start dividing out to find a slant asymptote. So I can just cross that out. So this would be our final answer, is that I've got a horizontal asymptote at y equals 1 half, vertical asymptote at x equals 3 halves, x-intercept at negative 3, 0, and a y-intercept at 0, negative 1.